Hi, Assalamualaikum. My name is Narana Hanafia. My metric number is AF19099. So our project title is to develop a model for Alarm A using HECRAS. We are from Group 8 and my group members is Muhammad Badrul Amir bin Hussein and Nur Aisyah binti Muhammad Samawi. Now let's take a look at the introduction part, which it contains problem statement, objectives, and study area. Natural disasters are the main cause of irrecoverable damages, and one of the most common natural disasters that happen all around the world is flood. Floods are now a common occurrence in most of the world, including Malaysia. Focusing on the subject of flooding in Malaysia, the state of Johor is one of the nation's frequent flooded agents. Flooding is a natural calamity that happens when a drainage system maximum flow rate surpasses what it can handle. Due to this issue, the river overflowed its bank, resulting in a flood to the region. Along the watershed, there are several drainage management structures, including storm drain, culvert, bridges, and water quality control structure. An essential part of hydraulic analysis is played by computer model, which make it easy to determine water surface profile under various flow circumstances, which in this project we use HECRAS. The main purpose of this project is to analyze the effectiveness of channel and provide suggestions to solve overbank flow by using section modification in HECRAS software, whereas in this section, modification with slope and marine value will be changed or modified until it is suitable depending on the channel given by the data. The objectives of our project is to analyze the effectiveness of drain and to provide suggestions to solve flood by section modification, which we will change the width, slope, and marine depending on the channel given by the data. For the study area, it is in Sungai Johor. The river has a length of 122.7 km with a catchment of 2,636 km square. That's all from me. Thank you.
Hi, my name is Nur Aisyah binti Muhammad Samawi, and I will explain about the methodology. Selection of data type. This study's data was gathered by conducting research at an drain connected to Sungai Johor. For the analysis of this natural river channel, 9 channels from downstream to upstream were carried out based on the given distance. Next, type of analysis. Steady flow water surface profile. One-dimensional river analysis with computation of the steady flow water surface profile. In order to evaluate intrusion on floodways, the steady flow approach is intended for use in research on flood insurance and flood plain management. This software program can also be used to analyze how water surface profiles are influenced by channel modification and level construction. Next, justification on the selection of analysis. First, starting a new project. The first step in establishing a hydraulic model with HECRAS, create a file and give the new project a title. Second, enter the geometric data. By selecting geometric data from the edit menu on the main HECRAS window, geometric data will enter. Third, enter flow data and boundary condition. The edit menu bar option on the HECRAS main window contains the data entry form for steady flow data. To display the flow data for each river station, 3 profiles of 5 years, 20 years, and 50 years are constructed. Pressing the Reach Boundary Condition button on steady flow data entry form will then display the boundary condition data entry form. The critical depth is the project specified boundary condition for both upstream and downstream. Fourth, perform a hydraulic computation. To perform the steady flow analysis, the geometry and steady flow file are selected. By clicking the compute button at the bottom of the steady flow analysis window, the steady flow calculation can be performed immediately. Fifth, viewing the viewing and printing result. The result can be seen once the model has completed the entire computation. Several output features are accessible through the main Windows view option, such as cross-section plots, water surface profile plots, general profile plots, rating curve plots, XYZ perspective plot, and tabular output are some of the options available.
Result and data analysis. Cross-section template design for sample using H 700. By using user-entered table, firstly, insert the data for the height, the width, and meaning. Then, the table will automatically generate the slope. You can see here that using the method of cut and fill, we are going to cut the original ground and fill the side area so that we can retain the water from overflow. And then repeat the same step for the other channels. Before and after modification, for example on H 700. Before modification, we can see that the area will be overflow even before 5 years. And then after modification using the method of cut and fill, first we will cut the ground area and will fill on the side to make a slope to retain the water. You can see here the water can be retained for 5 years, and then for 20 and 50 years the water will be overflow and cross the river bank.
I will be presenting the discussion part. The results shown at the previous slide from channel 0 to channel 1277.5 meter overflowing along the drainage ditch at the time of 5 years, 20 years and 50 years respectively. Therefore, a new channel design was created to prevent flooding in this area. These channels are modified with trapezoidal dimension as they possess a higher water capacity and therefore will help prevent flood in this area. We modified the drainage using the HECRAS Channel Design Modification Editor to enhance drainage efficiency to prevent flooding. And according to the final result of the modified stationing, there is no risk of flooding in this area of channel 0 to channel 1277.5 meter in Alu A over Sungai Johor in the ensuing 5, 20 and 50 years. Next is conclusion part. A user-friendly software package for developing floodplain maps is HECRAS. By inputting the river cross-section and river hydrologic data to generate the HECRAS model, flood analysis can be carried out. This software goal is to forecast if a river will flood over the upcoming 5, 20 and 50 years. Based on the developed drainage hydraulic system model, it is utilized to study the profile condition, the uniformity of the river's flow, and hydraulic characteristics. Furthermore, the use of HECRAS helps to reduce costs during channel arrangement design since the base size of the channel can be estimated. This is to prevent over-design of the channels. The natural river in this project flow to a region of Sungai Johor. The flood can be avoided by modifying and convert to a different arrangement in earth squander. The change was done to provide additional space and zone for the channel in order to prevent flooding of the riverbank due to stream flow.